Chapter number 7, alternating current. Now, in a previous chapter, we discussed about AC generator. AC generator produces alternatively changing voltage, means when this AC supply voltage is given to any circuit, then the current constituted, that is called AC current or alternatively changing current. Okay, we know this thing in our house or in our industries. The main supply, that is AC supply voltage, and this AC supply voltage is used widely because it is convenient to increase or decrease the voltage with the help of transformer in case of AC voltage, as well as it is easy to transmit from one place to another place, and it is also economical to transmit from one place to another place to this AC supply or AC voltage. So now in this entire chapter we will concentrate our mind on AC current. Okay, now see, first theory, when AC voltage is applied to a resistor, then what will be the current in the circuit? What will be the power consumed? That we have to discuss in this particular theory. Now see, AC supply voltage, that is represented by the symbol of circle with the sign of wave. Okay. Now this AC supply voltage is connected with resistance R. Suppose at a particular instant, the current in the circuit, that is I. Okay. Now here be careful, whenever for any AC circuit you represent the current in the circuit, then always represent time with it, because this one is alternatively changing current, means the direction of the current is continuously changing as per the positive negative half cycle of AC supply voltage appears here. Okay, so this is the current at a particular instant t, so that we have to represent. Now AC supply voltage V, that is Vm sin omega t. Okay, now as per Kirchhoff's second rule, we can write here, if current I is flowing through resistance R, then V equal to IR, and V, that is Vm sin omega t. So we can write I, that is Vm by R into sin omega t. Now Vm by R, that is maximum current in the circuit when the value of sin, that is 1. So we can write the equation now, I equal to Im sin omega t, where Im, that is Vm by R. And this is the equation for instantaneous current. Now here we can observe this thing. The voltage equation, that is Vm sin omega t, current equation is Im sin omega t. It implies that the phase difference between voltage and current, see, at a particular instant the phase of both one, that is omega t. So phase difference between these two means phase difference between voltage and current, that is equal to 0. Okay. Now average current in the circuit, that will be also equal to 0, because now in the circuit your current is continuously changing from plus Im to minus Im, depending on the values of sin omega t. Okay. Now Here, average current in the circuit is 0. It doesn't mean that the power dissipated here, that is 0. Current is 0. Power, that is I square R. So power depends on the square of the current. So it will not be 0. Now see, instantaneous power, that is voltage into current, that we can write V equal to IR, so I square R. So power P, that is I, that is Im sine omega t. So we can write Im square R sine square omega t. Now this is the instantaneous power at a particular instant t. Average power over one cycle, that is average of this Im square R, that is constant. So we have to take average of sine square omega t. So average power, that is Im square R into sine square omega t, that is 1 minus cos 2 omega t by 2. So we can write average power, that is Im square R by 2 into 1 minus cos 2 omega t. So Im square by 2 into R, 1 is constant. So we have to take average of cos 2 omega t. But average of cos 2 omega t over one period, that is equal to 0. So simply we can write average power, that is Im square by 2 into R. Now here, to represent power in the form of equation which we use for DC power, simply voltage into current, right? So here the effective current in the circuit is defined as RMS current. RMS current means root mean square current. Now root mean square current means, first of all, we have to take square of the current, then we have to take mean of it, and then after we have to take root of it. So let's see what will be the RMS current. See, we have the instantaneous current, that is I equal to Im sine omega t. Take square of it. So I square equal to Im square sine square omega t. Then after take average of it and then take square root of it. So I RMS, that is capital I, that is the effective current, that is under root average of I square. So capital I, that is, now I, that is Im sine omega t. So Im square and average of sine square omega t, because Im square is constant, and whole raised to 1 by 2. Again we can write Im square average of 1 minus cos 2 omega t by 2, because sine square omega t is 1 minus cos 2 omega t by 2. Again we can write here Im square by 2 and average of cos 2 omega t, that is 0. So simply we can write IRMS or effective current capital I, that is Im by root 2. Okay. Now directly we can write the RMS voltage also, Vm by root 2. If we solve in the same manner, V equal to Vm sine omega t, and we calculate VRMS, we will get the same value. Now see here, this Im square by 2. So Im square by 2, that is I square by 2, we can write, sorry, Im by root 2, that is your current I. So this one is our I square. So now we can represent power as capital I square into R, or simply V into I. So this one is, so when AC voltage is applied to resistor, what will be the instantaneous current in the circuit? What will be the average current in the circuit? What is the instantaneous power in the circuit? What is the average power in the circuit? And what is effective current itself is the RMS current in the circuit. All these things we discussed. Clear to all of you? Any doubt in this one?